very warm welcome to everyone. My name is Harshita Rathore and I am from class 11A. My topic for Nirmaan exhibition is customizing a diamond. So let me brief you about the topic. What is a diamond? We have seen different kinds of diamonds in our daily life, starting from rubies, emeralds, synthetic diamonds to many more species. Customizing a diamond is a very unique topic in which you use human DNA, starting from their hair to nails or other ashes to customize your diamonds. Let's start with the processing of our own diamonds. The first step of the process, as you can see over here, is grinding. In this, big machines are used in the factories to grind your particles like hair or other parts of the body like nails or ashes to use them as a main source of DNA for your diamond. In the next step, you can see some acid-like substances in the palette. These are nothing but the grounded particles of the DNA strand. We have to do some chemical process to get some carbon atoms. This looks like this and it has a complex chemical structure with a tetragonal sp3 hybridization. Step, these powdered particles are the main source of the diamond. So they are pressed until they form into disc-like circular structures, which are then put into a growth capsule and they are then put into a growth chamber. This growth chamber actually looks like this, and the diamond is then kept in it for weeks under high pressure and temperature, and it gives us the main source of our diamond. Taking out the mature diamond out of our growth chamber, we are going to put it into a solution of hydrogen peroxide, concentrated nitric acid, concentrated sulfuric acid, and concentrated hydrochloric acid. So let's do this. After a while, you can see some bubbles that are formed into the chemical. These are nothing but the impurities that except for carbon that are coming out of the particles. Out our diamonds out of the chemical, we can see some concussions of alum-like substances. These are the pure diamonds. They are completely carbon atoms with a sp3 hybridization. After this, we have to just plan the diamonds and do the cutting and processing of the diamond. And we'll get a perfect diamond-like shape. Every diamond has a unique shape, texture, color, and even the light. This is because of the cuttings of the diamonds, which are done in big machines, using big machines. And the last step, that is inspection, we have to use such type of instruments to look through the diamonds. Each person has a different mirror according to their iron numbers. In the end, I would like to brief you about some career options that are available for people who are interested in these sectors. Career options like mining industries, jewelry manufacturing industries, and art auction houses are readily available for people. Thank you.
Good morning everyone. My name is Maloni Tank and I am from class 11th A, and my topic for today is forensic science. Forensic science occupies the intersection of law and laboratory analysis. These crime-fighting professionals carefully collect, process and document pieces of evidence that are often invisible to the naked eye. So what does that forensic scientists actually do? Forensic science work occurs in two environments. Firstly, collecting evidence from crime scenes and analyzing evidence in laboratories. This can be explained by the means of the two following experiments. First is forensic fingerprinting. In this experiment, we will be using liquid iodine to reveal latent fingerprints on paper and other porous substances. Here, I pour iodine solution into the chamber and place the paper to be tested on top of it. After leaving the specimen in the chamber for a few minutes and then on extracting it, we observe brown stains, thus revealing the fingerprints. Second is forensic chromatography. In this experiment, we will be using rubbing alcohol or isopropyl alcohol to see the difference between the inks. The first glass contains a sample to be tested, whereas the second glass contains different inks for comparison. As the alcohol rises, the ink separates into its constituents, thus revealing different patterns. On comparison, the separation of the ink labeled A matches with the sample. As technology advances, the use of forensic information is expected to increase, ranging from microbiome testing, DNA genotyping, epigenetics, and even virtual autopsies. The scope of forensic science as a viable career path is wide open. from matching shell casings to guns that fired them, to using hair samples to identify a suspect. Forensic scientists help to determine the facts of a legal case. Thank you.
Hello, my name is Sean,
My name is Prajwal.
and the topic of our project is manufacturing of scented candles.
Scented candle is a candle infused with essential fragrant oils. Scented candles are mainly used in the hospitality industry, mainly in hotels and spas. Many customers use it for its relaxing properties. Aromatherapy is used for relaxing and calming the mind, and it also helps your mind enter into a productive state.
A scented candle is long lasting and will continue to release scent even after you have drifted into a nice sleep. In fact, the effects of lowering stress, heart rate, and blood pressure continue and helps keep you at an optimal level of relaxation. Now let's see how these candles are made. The primary components of scented candles are paraffin wax and essential oils. The wax should be melted using a double boiler. The optimal temperature to add the essential oils into the melted wax is 80 to 90 degrees Celsius.
Making scented candles are really easy and affordable. This gives rise to many small businesses all over the globe.
The global market value of scented candles in 2020 was 533.5 million and is expected to grow by 3.3% annually from 2021 to 2028.
These are the benefits of scented candles at the employment level. The growing demand and value of the industry can result in a successful business. These provide employment to underprivileged people.
Good morning everyone, my name is Navya Khanna and my topic for today is genetic mutations and my profession is genetic engineering. The Human Genome Project estimates that the human genome consists around 20,000 to 25,000 genes. Each of these genes is made up of hundreds to millions of DNA nucleotides. Sometimes only a single DNA mutation, that is change in DNA sequence, can result in a person having a devastating genetic disease, and researchers have been able to identify several such different mutations and conditions. But sometimes a DNA mutation may cause no harm at all. It all has to do with what the DNA mutation is and where it is located. Each gene in the human body consists of DNA. As seen in this model, DNA is a genetic code that is made up of 4 different types of nucleotides: adenine, thymine, guanine, cytosine. The DNA code is turned into RNA, ribonucleic acid, in our bodies in a process called transcription. In RNA, a nucleotide called uracil substitutes for every thymine. The RNA then goes into a process called translation to turn into amino acids. During translation, every 3 DNA nucleotides code for a single amino acid. Many things can happen during this process to prevent a gene from turning into a protein or to have a non-functional protein created. If in a gene a single DNA nucleotide is mutated, for example, from an adenine to a guanine, this may cause the wrong amino acid to be made. If the wrong amino acid is made and assembled into a long chain of amino acids, the resulting protein may not work. This is because different amino acids are different in many ways, such as size and electric charges they have. For example, positively and negatively charged molecules prefer to interact with each other and with water, which is called being hydrophilic, whereas non-polar molecules do not like to interact with charged molecules or with water, which is being called hydrophobic. These seemingly small differences can have very large consequences. For example, in cystic fibrosis, there is a mutation in a gene called CFTR gene that encodes for a channel that controls the flow of particles in cells. Specifically, this channel controls the flow of small negatively charged particles called chloride ions, which can flow into or flow out of cells. The movement of charged particles acts to balance the flow of water into and out of cells. Cystic fibrosis is an inherited disease characterized by the buildup of thick, sticky mucus that can damage many of the body's organs. The disorder's most common signs and symptoms include progressive damage to the respiratory system and chronic digestive system problems. The features of the disorder and their severity varies among affected individuals. Mucus is a slippery substance that lubricates and protects the linings of other organs, tissues, airways, digestive system, and reproductive system. In people with cystic fibrosis, the body produces mucus that is abnormally thick and sticky. The abnormal mucus can clog the airways, leading to severe problems with breathing and bacterial infections in the lungs. These infections cause chronic coughing, wheezing, and inflammation. Over time, mucus buildup and infections result in permanent lung damage, including formation of scar tissue, that is fibrosis, and cysts in the lungs. Most people with cystic fibrosis also have digestive problems that result from a buildup of thick, sticky mucus in the pancreas. The pancreas is an organ that produces insulin, a hormone that helps control the blood sugar levels. It also makes enzymes to digest food. In people with cystic fibrosis, the mucus often damages the pancreas, impairing its ability to produce insulin and digestive enzymes. Problems with digestion can lead to diarrhea, malnutrition, poor growth, and weight loss. In adolescence or adulthood, a shortage of insulin can cause a form of diabetes known as cystic fibrosis related diabetes mellitus. Cystic fibrosis transmembrane conductance regulator. The CFTR gene provides instructions for a protein called cystic fibrosis transmembrane conductance regulator. The protein functions as a channel across the membranes of cells that produce mucus, sweat, saliva, tears, and digestive enzymes. The channel transports negatively charged particles called chloride ions into and out of the cells. The transport of chloride ions into and out of cells control the water movement in tissues, which is necessary for the production of thin, freely flowing. The CFTR protein also regulates functions of other channels, such as those that transport positively charged particles called sodium ions across cell membranes. These channels are necessary for the normal function of organs such as lungs and pancreas. Other names for the CFTR protein are ABC35, ABCC7, CAMP dependent chloride channel, CF, CFTR human, MRP7. Cystic fibrosis is inherited in an autosomal recessive manner. It is caused by the presence of mutation in both copies of the gene for the cystic fibrosis transmembrane conductance regulator protein. There is no known cure for cystic fibrosis. Lung infections are treated with antibiotics, which may be given intravenously, inhaled, or by the mouth. Sometimes the antibiotic azithromycin is used for long term. Inhaled hypertonic saline and salbutamol may also be useful. Lung transplantation may be an option if lung function continues to worsen. The average life expectancy is between 42 to 50 years in the developed world. Lung problems are also responsible for the death of 80% of people with cystic fibrosis.
Hello everyone, my name is Athar and my topic for today is Wellhead Tower. It is also known as Christmas tree in the oil and gas industry. This is the model of a Christmas tree and it is a vital part in the oil and gas industry. It is used in the extraction of oil and gas and it also provides the structure and pressure controlling interface for the production equipment. It also serves as a suspension point and pressure seals for the casing strings which flow from the bottom of the wellhead to underground seabeds or land. Now what are casing strings? Suppose this table is the seabed or the land and this is the bottom of the wellhead. Then the casing strings are the group of connected pipes which flow from the bottom of the wellhead to the seabeds and allow the flow of oil and gas. Now let's look at the other component of the wellhead tower too. This both are known as the master valves, the upper master valve and the lower master valve. Their function is to either allow the flow or either shut down the flow depending on the requirement. They are in two numbers as they can provide us the backup if either one of them is under maintenance or stops working. This is the keel wing valve. Its function is to inject fluids such as methanol or corrosion inhibitors in the well to prevent the formation of hydrate. This is the swab valve. It gives us the vertical access to the production well, and it also allows us to monitor the entire system. This is the production valve. It is an automatically active valve and it can stop the entire system under any cases of emergencies. This is a surface choke. It controls the rate of flow of the production under the well and also it maintains the pressure through which the production is going on. This is the tree cap. It is a visual indicator of which valves are working in the Christmas tree. For example, if keel wing valve is on and the swab valve is off, then the number indicated on this meter would be 0. Now this is just one example of Christmas tree. Similarly, there can be 3, 6, 9 or 12 Christmas tree on one wellhead tower depending on the requirement. This all Christmas tree go and forms one manifold through which the oil production is sent to different places. Now I will show you one slide demonstrating how this wellhead tower looks like. Thank you. This picture is the model of one of the wellheads in the city of Abu Dhabi. In the box marked right here, you can see number of Christmas trees which are connected by the casing strings, and these casing strings are lowered into the seabeds. Through these casing strings, the production and extraction of oil and gas happens, and the oil and gas is then transferred to various places.
Greetings everyone. Today, I, Ishika Bhardwaj,
I am Mihir Chotrani.
And I am Morish Mishra.
are going to represent the process of electroplating and electrolysis of metal.
Electroplating is a process where we can deposit a metal to other substrate through electricity and chemical processes. Types of electroplating coatings are sacrificial coating, functional coating and decorative coating.
For this experiment, we have taken the product as a reactant and electrolyte solution is sulfuric acid and copper sulfate solution. Cathode is the place where we place the part to be plated and anode is the copper metal. We have also used a rectifier which changes AC current to DC current.
The process of electroplating works on Faraday's laws of electrolysis. The electrolysis is the process by which a substance can be decomposed into simpler substances when electric current are passed through them. The Faraday's laws of electrolysis states that the amount of chemical change occurred when an electric current is passed through them is equal to the electricity used. Second law states that the amount of electricity chemical changes produced during the same quantity of electricity is different. Substances are proportional to their equivalent weights.
As we can see here, this was the plated part and this was the part before electroplating and this is the part after the result. It has acquired the coating of copper. The rising demand for electroplating from different end-use industries is propelling the growth of the market. Nowadays, electroplating has become an inevitable part of many industrial fields, including automotive industry, white goods industry, consumer electronics, fashion and cosmetic industries, and sanitary and plumbing.
Many plastics are plated today, including ABS, polysulfone, Teflon, mineral reinforced nylon, which is MRN, etc.
Manufacturers are continuously launching new substrate materials for electroplating which are environmental friendly, with surging demand for materials such as plating on plastic which improves the product. The electroplating demand is set to grow steadily by 2030. Thank you.
Thank you.